In the last video, we talked about all the different properties of addition and how all the information from addition encapsulates all of the information from subtraction. In this video, I'd like to talk about the other two operations, which would be multiplication and division. So let's start with multiplication. Like addition, it is a function from R cross R to R. That means it takes two numbers and gives me one number. And if I think about the properties of this multiplication, I can ask all of the same questions as I did for addition. Is this multiplication operation associative? If I will abbreviate here, because I don't like to write big words. Let's see. Well, if I have A, B first, A times B, then multiply by C, is that the same as A times B times C? And if you've worked with numbers at all for any substantial period of time, you will remember that yes, this is true. My multiplication operation is indeed associative. Let's talk about commutative. Well, A times B equals B times A. And again, yes, this is true. The identity property. Now, the identity property of addition, if you remember, involved a special element, which was 0. And when I added 0 to any element of the reals, which would be any number, I get that number back. Now, for multiplication, I also need a special number where I have A times whatever number is going to go here is equal to itself, A. What number is this? Well, it's 1. A times 1 is A, no matter what real number you have. I guess I should write a quantifier here to show that for all A, this is true. This is for all A and B. This is for all A, B, and C. Quantifier is not the important part of this statement. The important part is the statement itself. Maybe the last property that I'll want to think about is this inverses property that I talked about. And the idea about the inverses property is if you have any number, and when we were doing addition, we had any number, and then we added another number, we got 0. And this other number was always minus A, right? So for multiplication, I want A times some other number is equal to 1. So what is the number? It's 1 over A. A times 1 over A. You'll cancel the A's here, and you'll get 1. Okay. Now, what about 0? What's wrong with 0? Well, what's 1 over 0? Well, it's not a real number. So really, what I have to say is that this inverses thing works unless A equals 0. And if A equals 0, it breaks. Because 1 over 0, whether you want to call it infinity or whatnot, 1 over 0 is not a real number. Infinity is not a real number. So how can we fix this? We have a multiplication, and it has 3 of the 4 properties that addition has, but it doesn't have the last one. So how can we sort of fix this? Well, this is a sort of a theme in mathematics. If you do mathematics for a while, is you ignore everything where there's a problem. That's right, ignore your problems. All right, so how do we ignore our problems in this case? Well, we just don't want to think about zero. So I'm going to use some set theory notation here to say R with a set difference of 0. And I'm going to define multiplication on only non-zero numbers. So it's a function from R set difference 0 cross R set difference 0 to R set difference 0. And finally, once we've done this, so this R set difference 0 is just another way of saying the non-zero real numbers. And once we've done this, we can see that we have found something that has exactly the properties that we want. Associative, commutative, identity, they're all inherited from the structure on R. Inherited just means that they were properties of the things on R. They were true for all the numbers on R. So when I talk about a subset of R, they're still true, because if it was true for everything, it certainly better be true for a smaller subset of everything. And the inverses property, now that I'm ignoring the case where a equals 0, is also true. So I'll have a check, 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 and a check. And the last comment I should make is division is actually, it's a lot like subtraction. In fact, it's exactly like subtraction. Division from our, now we have to say no zeros, because we still can't divide by 0. We still don't know how to divide by 0. Cross our set difference 0 to our set difference 0. Division, it's also not associative, which makes it really, really, really hard to deal with. And not only is it not associative, it is sort of like subtraction. It can be completely understood through multiplication, right? So I'll take something like, if I want to divide 3 by 5, right? Or if I want to divide 15 by 3, this is the same thing as 3 times 1 over 5. And this is the same thing as 15 times 1 over 3, right? And so all of these things here can be thought of as multiplication, just as long as I include all of fractions in my numbers. And because I'm thinking about all the real numbers, I certainly am including fractions. And so we don't think about division, we just think about multiplication. And from the perspective of algebra, the thing that I want to illustrate here is that addition and multiplication, once we've looked at just the algebra, they're the same. And so we want a way of defining something that has all of these properties. And that's what we'll do in the next video.